Hi, very good afternoon, everyone. Thank you for joining me in another session of Tech Tarik Time. This time we have the topic of what is Wi-Fi 6 and Wi-Fi 6E. And we are lucky today to have our speaker, Mr. Chang, the Senior Field Marketing Engineer from Anritsu, Singapore. So welcome, Mr. Lee. How are you?
Hello, hi. Thank you, Prof. Yusuf. Yeah, I'm
Uh,
fine. So I'm very happy to be invited to give some sharings on this Wi-Fi topics today. Yeah, I hope you all
okay,
can
thank
learn
you.
more after today's sessions. Yeah.
All right, thank you for your time. So before I let you do the talking, let me just introduce a little bit about yourself to
Mm,
the audience so
mm,
that they know who you are.
mm,
Mr. Lee Changfan is an Anritsu Senior Field Marketing Engineer, is
mm,
dedicated to the signaling test solution for the latest mobile and wireless technology development. The scopes of support range from leading R&D, design verification, conformance testing and mass production in the ASEAN region. So before joining Anritsu, Mr. Lee has already worked under the A-Star Institute for Infocom Research, I2R, for wireless communication planning in National Smart Sensor Deployment and Electrical Vehicle EV Development Project. In his early career, he used to design cellular products from concept until product realization, and this forms a solid foundation in his Anritsu role now to provide technical consultancy. He has gained his Bachelor of Telecommunication Engineering from the University Technology Malaysia UTM Johor.
mm.
So, without any further ado, I leave it to you, Mr. Lee, for sharing about the Wi-Fi 6 and also the Wi-Fi 6E. All over to you.
Yeah. Thanks, Prof. Yusuf. Yeah. Okay. So good evening, everyone. So now I want to share my screen. Yeah. This is my screen. Yeah. Cameras. I think you all can see my screen. Yep. Hope there's no technical issue here. Okay. So first, yeah, this is a very good. I think it's a good sections for this. I think the name for this seminar is also very good. Direct time. Yeah, it's a good name. So today I'm going to share the Wi-Fi 6 and Wi-Fi 6E. So my name is Chang Fatt, or you can remember for you is call me CF lah, just easier. Okay. So if you have any questions during my sessions, you can let me know. So I can help my best to answer your questions. Okay. Okay, this is my today topic. So of course, first I will introduce my company profiles. Okay, this is a very short one. Okay, and then about the Wi-Fi 6 wireless LAN market update. So Wi-Fi 6E. Okay, and then the IEEE 802.11x standards, and then how you are going to test this standard with Anritsu solutions. Okay, in the end of this sessions, I will also share some of the Anritsu wireless LAN resources to you. So if let's say you are really doing this kind of study, you can go export a lot of Anritsu resource, utilize it, and then I think it will help you, okay, in your study. Okay, okay, yep. So let's first is a company profile. This is a Anritsu company. So Anritsu company is from Japan. Okay, it's a lot of have a years of history. Okay, I think to for until this year is about 127. Okay, so it's formed by two gentlemen here, Anaka-san and Sekisha-san, since 1895 and 19 1900 years. Okay, so they first formed from the wireless technology and then wired to together. So after that, in about 1985, they formed Anritsu corporations. Okay, until to this today. Okay, so Anritsu have a lot of equipments. Okay, test equipments. Okay, from Japan. So that I think the since 1914, so you have some world first radio telephone services. Okay, so also some broadcast solutions, and then until to the end, I think the latest one, the topic, hot topic is a 5G. Okay, okay. Of course, today we are talking about Wi-Fi, so we will share about Anritsu solution for Wi-Fi also. Okay, okay. This is our headquarter. Okay, in Japan. So, okay, it's a very good buildings. Okay, it's near. I think it's near Tokyo. Actually, it's a place called Kanagawa. Okay, I think about 1 hour drive from Tokyo. Okay, and then this is our studio Hamada-san. So we actually have a lot of entities. So not only for test and measurements, actually we've got some food and safety and some components and IP network equipment also. Okay, but of course the first role actually is a T&M test and measurements market. Okay. Okay, I myself, as introduced by Prof. Yusuf, I'm a technical support engineer in Anritsu. Okay, of course, before actually 2 years ago or before COVID, I'm actually very active in giving some talks. Okay, for example, I'm also giving the talks for IEEE. Okay, this is a talk for microwave in 2017, and also some 5G talk for this IEEE events also, MESS. Okay, and then go to some hotels, some university. I think this is in Indonesia. Okay, give some sharing to them also. Okay, of course today it's good to have a online sharing session also, so it can actually cut some journey expenses. Okay, but of course there's a good and bad between the on offline and online. So in one day, I hope actually I can go to MMU or other place of Malaysia to give some kind of sharing. By the way, actually, I'm from today. I'm from Anritsu, Singapore. So we are giving the online sharing session today. Okay. Okay. So first is the wireless LAN market updates. Okay. Wi-Fi 6E. Okay. Of course, Wi-Fi now is very popular now. Okay. Wi-Fi, I think almost major of the IoT solution they are using a wireless LAN as a transmission technology, wireless transmission technology. So of course, first you can see they're using in automotive. Okay, the car. Okay, I think in the infotainment inside the car. Okay, then of course the home use is a smart home, like the Wi-Fi routers, electrical goods, even the vacuums. Okay, and then the manufacturer. Okay, the facility management, robotics, remote controls. Okay, and then I think now it's another getting very famous topic is AR and VR. So this is applications for metaverse. I think last November that I think Facebook they have ideas. They start to push or promote this metaverse technology. I think in 2-3 years, this metaverse will become more and more mature, and this technology will mostly occupy or mostly utilize the Wi-Fi technology to execute, okay, or to realize it. Okay. Okay, so hot topic about current Wi-Fi news is there are new frequency to be adopted. Okay, it's a frequency about 6 gigahertz. So this frequency previously is not using by the unlicensed devices. It's used by some kind of devices like broadcasting or satellite. So then there's ideas actually to release these spectrums, okay, from 5 to 7.125 gigahertz. Okay, so with this release, the spectrum release, we actually for the Wi-Fi, the Wi-Fi have have more bandwidth to be used, about 1.2 gig. Okay, extra spectrum to be used. Okay, so a lot of countries actually they are start to adopt it. Okay, of course the first one is from USA. Okay, the FCC in USA already approved these spectrums in the year 2020 about April. Okay, after that there are lots of countries follows like UK, Korea, Chile, then year 2021, Brazil, UAE, Canada. Okay, and then I think Europeans also follow. So yeah, there's a lot of countries follow these spectrums release. Okay. Okay, why we need to open the 6 gigahertz frequencies to be used for either Wi-Fi or other technologies. Okay, of course today we focus on Wi-Fi. So of course with a higher bandwidth, with a higher frequency, you will have more bandwidth to be used. Okay, you have extra 1.2 gig to be used. Okay, previously, if let's say you still remember in Wi-Fi technology, there are the plans to use 160 megahertz. Okay, but this 160 megahertz always cannot find. If let's say if you're using at the 5 gigahertz or 2 gigahertz bandwidth, okay, frequency. Okay, so with this open of the spectrum, we can realize we can have more 7 channels for 160 megahertz. So this bandwidth now it becomes more realistic to be used. Okay, so with the Wi-Fi 6 gig, you also have a faster AP discovery. Okay, with some improved scanning methods, And then the security we also improved by the latest WPA3 technology. Okay. Of course, there are some challenges of when using these 6 gigahertz. Okay, so of course, first thing is the power requirements, because as I mentioned just now, this 6 gigahertz frequency now is using by some kind of other devices like the some fixed services like FSS, okay, like satellite and broadcast system. So that's why when we want to using this frequency for Wi-Fi, we must have some power rules, okay, some power requirements. Okay, they actually have some indoor and outdoor requirements. Okay, so they need to limit the power, especially for the outdoor usage. Okay, so for the normally for the Wi-Fi 6 gig, you are still still okay to use in the indoor. But if let's say we're using it for outdoor, there's a lot of rules that you should follow. First thing, there's some scheme maybe called AFC, okay, actually to limit the power. Okay, when you have the Wi-Fi 6E devices, you need to make sure that your devices actually may have some power control. Okay, so this is some kind of power limitations. Okay, when using in this kind of region, there are about Uni 5, Uni 6, 7, 8 regions at this frequency. So these regions actually have some other application. So when you're using at this Uni 5 you may need to have some limitations. Okay, like 36 cannot be more than 36 dBm, or maybe cannot be more than 30 dBm for low power devices. Okay, so there are some power rules to follow. Okay. Okay, one thing to update is about MCMC in Malaysia. Also, they are also very they aggressively to do some survey on this 6 gigahertz frequency band using 6 gigahertz for Wi-Fi. Okay, so I think last year they actually do some surveys. They collect a lot of opinions from a lot of companies. Okay, to check whether we should release the 6 gigahertz for Wi-Fi usage. Okay, I think last month or last 2 months they already have some results. So I think they have some conclusions. I think this month. Okay, I think if not wrong, they allowed the 6 gigahertz to be used in Wi-Fi. Okay, I think there's still the solid result you can find from the website. Okay, the Wi-Fi 6E products. There are a lot of Wi-Fi 6E products actually in the market. Okay, Wi-Fi 6 a lot. Then now Wi-Fi 6 means 6 extensions. Means products for used to be used in 6 gigahertz frequency. So this is the records that I got it from the Wi-Fi Alliance website. So for example, like in the product level, you can have some Asus router, okay, Netgear router, even the Samsung Galaxy S21 also support Ultra. Okay, and then for the chipset level and module level, there are solutions from Intel, Broadcom, Infineon, MediaTek, or there are a lot actually support the 6E. I think very soon in our region, our Asian region, you will see some Wi-Fi 6E product also. Okay, I think because Malaysia is the first country that may deploy the Wi-Fi 6E, so we may see some products in Malaysia first. Okay, I think even in Singapore, there are still a lot of discussions. Okay, so still not yet have any conclusion yet for this frequency usage. Okay, so now talk about Wi-Fi 6 standard. Actually, I name it IEEE 802.11ax. Okay, they are the similar name. So this is more to engineering name, like under the IEEE. So for marketing or for easier to the consumer to know, we normally name it as a Wi-Fi 6. Okay. Okay, as I mentioned, so you since 2009, so we have 802.11n. So after that we have AC, and then 2019 we start rename it to Wi-Fi 456. Okay, 4 is means refers to IEEE 802.11n. Okay, and then 5 is for AC, 6 is for AX. Then 6E is for frequency to be used in 6 gigahertz. Okay, or we call it 6 frequency extensions. Okay, until this year. Okay, there are a lot of standard. This is the very technical details for all the standards. So from the very initial one, B, then A, G, and ACX. So what is the difference? First, of course, the name. They also they're using different the formats to name it. So for X, we actually call it high efficiency. Okay, AAC is a VHT, very high throughput, and N is high throughput. Okay, so this keep going, keep revolving. Okay, until only the AX we have the frequency 6 gigahertz to be used. Okay, then the bandwidth also keep increasing. Okay, AC is about 160 meg, and then X will continue to use the X bandwidth. Okay, and then the speed uh, is up to 9.6 gig for X, so it's a quite a high throughput. Then another very unique thing is the modulation scheme. So modulation scheme can go in the X, it can go to 1024 QAM. So it is very advanced modulations methods. Okay, and then the stream. So from 4 times 4 MIMO into 11N. So now we can go to X times X MIMO. So in the X, we actually got one more features called OFDMA. So I will explain later what is OFDMA. Okay. So this is the Wi-Fi 6 key features. So I capture these pictures from the Wi-Fi Alliance, Wi-Fi organizations. So there are about 8 features. So the first thing is the multi-user MIMO. Okay, so you can have more users at the same time for downlink and uplink. Okay, OFDMA is another access technology. So later I will explain more in my next slide because these are the key features. So beamforming. So you will have a better receptions with the beamformings because if you direct the beams to the certain devices. Okay, more bandwidth, 160 megahertz bandwidth. Okay, and then there are some technology called target wake times to always monitor the wake up time and also the sleep time of the DOT. Okay, to make sure the devices can always can save the energy and also can always get attention with the route AP or router. Then there's some kind of called BSS coloring. So BSS coloring is good for the usage of the frequency. If let's say this frequency has overlapping between each other when they are using at the same AP, so they actually have some color scheme to differentiate the route, the AP. Okay, and then the spatial streams is the MIMO schemes. Okay, go up to 8 now, and then the modulations that I mentioned just now. Okay, so first thing, the important thing is 160 meg. Okay, as I repeat quite many times. Okay, so because in the 2.4 gigs you want to use 160 megahertz, it's very difficult to find. Okay, you want to find here in 2.4 gig you only can get the 40 megahertz bandwidth. Okay, in 5 gigahertz you only can find 2 slots that can use the 160 megahertz. So that's why it's not so practical to use 160 megahertz when you only have 2.4 gig and 5 gig to be used. But if let's say today we have 6 gig to be used for Wi-Fi, you actually have 7 more slots to be used. Okay, so this will improve the congestion situations. Okay, and also it become more practical. Okay, because we also know 2.4 and 5 gigs have a lot of devices are using it. Okay, with the open of 6 gigahertz, you can have it will avoid a lot of congestion issue. Okay, another very important feature is called OFDMA and also MIMO downlink uplink. Okay, so OFDMA previously in AC level, we are only using OFDM. So, for example, here is the resources of your of your resources. Okay, of your spectrum. So you can divide to the subcarrier with the subcarriers, many subcarriers, and versus time. Okay, so previously you only have in certain time slot you only have for one user. Okay, this is for the green user, this is for the pink user, this is for blue user. So different users occupy the Wi-Fi spectrums at different time slot. But with the technology called OFDMA, so you actually can share the resources with over different subcarriers and different time slot. Okay, so these users can hold the time slot here, and they can occupy certain subcarrier only to transmit and with other devices. So with this, you actually make use of the frequency resources. So all the frequencies actually is a limited resources. So with this OFDMA, you can save a lot of spectrums. Okay, and then another one is called MIMO downlink and uplink, because previously in AC we actually also can do MIMO, but it's more to downlink. Okay, so for example, if let's say today the access point, you send the message to product A, okay, at the same time it sends to product B. Okay, when the product respond for product A, they will respond separately at different time slot. Okay, this one respond now, and then this one respond later. Okay, so this is only sequential response. But with less to the technology today's AX, so actually both devices will respond at the same time. Okay, the station, the product A and B will respond at the same time to the AEP. Okay. Okay, this is what I mentioned in the AC. You only cover the downlink multi-user, but for X, it can cover the uplink also. Okay, another one is the modulation scheme. Because of the Wi-Fi 6, you can use a better modulation scheme. Okay, with higher modulations, you carry more symbols. Okay, for 1024 QAM, you can carry 10 bits per symbol. Okay, for 256 QAM, you only can carry 8 bits per symbol. So with using the same time and same resources, with the higher modulation scheme, you can carry more symbols. Means you can send more data bit, and then increase all your application speed. Okay. And then in the market, actually, there's still one more standard coming called IEEE 802.1BE standards, or we may call it a Wi-Fi 7. Okay, we name it Wi-Fi 7. Okay, with this Wi-Fi 7, you will go even up to 30 gig per second. Okay, just now it's only 9.6. So, but this is it should be planned in 2024. So I will not share too much today. So I just let you know that we actually have this 11BE, okay, in the future. So I think it's still also the hot research topic now. Okay. Okay, so now let's after we understand what is the market situation for Wi-Fi 6E and also the theory for the Wi-Fi 6. Okay, so now let me share some about Anritsu's solution on how to test this Wi-Fi 6 devices. Okay. Okay, Anritsu actually have some test equipments to test it. Okay, first is the signaling tester. Okay, signaling tester. Okay, secondly is we call it non-signaling tester. So there two have the difference. So the first one may be more for R&D levels, okay, for product development. The second one is more to mass production, because the first one, this tester work in the network mode. Okay. This one is work in the direct mode. Later we will explain what is the difference between network mode and direct mode. Okay. Okay. Of course, today if let's say you are developing a DUT, okay. For example, you are doing some kind of mobile phone, you're doing some kind of remote control, okay, you're using Wi-Fi technology. So this is your device under test, or we call it DUT or DUT. So you can actually test with a tester, okay, to a tester. Then, because your DUT is the station, so the tester can become a access point, okay. So they each will will communicate each others, and then through the communication we can measure the RF performance. Okay. So if let's say today you are doing some kind of router design devices, okay, some access point device, gateway. So this is your, then our tester can become a station mode. So that's why you have a flexibility to switch between the IP mode or station mode for this tester. So this is some kind of very networking mode, okay, or signaling mode, okay, because you are testing with the tester as in the as this tester is like real IP in the market. Okay, we can call it golden access point. Okay, because this is a tester, so we make it as a golden unit. Okay. Another one is the I mentioned this one is a non-signaling tester, or call it MTA70A. So this is the non-signaling tester. So how is this tester working is actually is a signal generator and signal analyzer. Okay, these two they form into one. So today, if let's say this is your Wi-Fi devices, you are doing some kind of development, so you want to test the transmit power, you have to commands your devices to send the signals, and then this tester work as a signal analyzer they will analyze your signals. Okay, if let's say today you want to test the sensitivity of these devices, so this tester will become a generator. They will generate some waveform, and then this DUT will read the sensitivity. Okay, then after that to check whether your devices have a good RX performance. So this is a difference between the signaling and non-signaling. Okay, non-signaling basically is a SIGGEN and signalizer together. Okay, so you are using SIGGEN and signalizer to measure your Wi-Fi devices. Okay. Anyway, today we will more focus on R&D or more focus on this. I will share more what I did for this AX testing. Okay, because I did a lot of Wi-Fi 6 devices testing for router or for other station like for mobile phones. Okay, so I will just share some of my experience when I help the industry people to carry out the testing. Okay, so just let you know the products, some kind of product feature of this tester MTX62A. So basically, it's a powerful tool to measure the RF performance. Okay, so for the in a network mode, actually you also can support direct mode, but we are the unique part here is to support the network mode, okay, or signaling mode. Okay, support up to 6 gigahertz. Okay, you can all the bandwidth according to IEEE 160 megahertz, and then it support the WPA3 security also, personal security. Okay, so you have a very good graphic or GUI, and then the RS measurement is also very easy. Okay, later I will share more all the test results. Okay. Okay, in the AX evaluations, there's something very special. Okay, on Wi-Fi 6 RF evaluation, because the Wi-Fi 6 they have a different kind of formats. Okay, or the PBDU, the protocol data unit. So this kind of frame format, normally the frame format is like formed by some kind of the header and the data. Okay, they got some the correction error code, all these kind of packets. So they have different format and different usage. Okay, for example, we have a single user. Okay, and we have also a multi-user. Okay, and also extended range single user or trigger based. So what is the difference? Okay, so single user is a normal testing. So like the AP to station 1-to-1 single, so 1-to-1. So this is a simple case. So you only have one station to work with one access point. So this is a normal situation happen in the BGN standard also. Okay, because they are doing at the one at the same one only, they are doing sequentially, so we can call it a single user. So the unique thing here is a multi-user. Okay, because just now I mentioned in the Wi-Fi 6, the Wi-Fi 6 have the new features called multi-user. Multi-user MIMO uplink and downlink, and also they have a different modulation scheme, the multi-access scheme, the OFDMA. So if let's say you're a multi-user, your AP actually will work with a lot of stations. So this station actually need to react according to the AP signals. Okay, so they will react to the AP signal by using this trigger-based signals. So there are a lot of different packet here. Okay, so for example, today you're testing for station, so you have a lot of things you can test or cannot be tested. Okay, for example, you have a single user, of course it can be tested. So some you can see is not applicable because it's not practical. Because if let's say you want to test let's say your DUT is a stations, you are testing this station cannot send the multi-user packets. So they only can say the trigger-based packet. That's why you only have this is not available. Okay, some are not defined yet. Okay, so that's why this you can see this kind of support scheme of the test scenario. Okay, so this will have a station and also for access point. Okay, both are different. Okay, traditionally, previously, this is all the RF, very general RF testing for Wi-Fi, means 11 IEEE BGN or AC. So very, very, very typical training, testing like emission mask, spectral flatness, okay, central frequency leakage, constellation error, EBM, or sensitivity parts, okay, all under the IEEE chapter testing. But for AX, we actually added 4 more items, basically for the trigger-based packet, okay, for the multi-user cases, okay, multi-user case. So we have to make sure the station actually can respond correctly under the multi-user scenarios. So that's why we add these 4 test items into the AX testing. Okay. Okay. This is some technical study for the first one for the X features. Okay. For trigger base. First is the transmit power and RSSI. So we make it simple. So you have to make sure when this AP it transmits the power to the station here. So the reporting power or the RSSI they have to be the power accuracy had to be in the tolerance of 3 dB or different limitation for different device classes. Okay, we've got class A or class B. So you need to make sure the power reported is correct. So that's why we have this testing, first testing. Okay, so there's an absolute transmit power, there's RSSI measurement accuracy, and relative transmit power accuracy. So the tolerance for the reporting must be correct. Okay, this is the first thing. Okay, it's a power related. Secondly, is the carrier frequency offset error. Okay, so we need to test this carrier frequency offset. So why we need to test? Because in the X we are using OFDMA technologies to support multi-users. So that's why the frequency setting carrier frequency offset measurement is very important to make sure you can support this kind of OFDMA technologies more efficiently. Okay, so first you have to make sure you must make sure your CFO cannot exceed 350 hertz when the CCDF become less than 10%. So with our equipment we tested, so we have to make sure under this CCDF level, okay, cannot more than 350 hertz. So this is one kind of frequency offset testing. Okay. Then next is the EVM testing. So for the unused tone, there's a very a lot of formula here, but not worry. We make very simple using a tester also. So we actually can check the mass, the emission mass. When it is unused, you cannot over the green line here. Okay, so for example, here is unused unused resources here. Okay, so you cannot over the green line here. Okay, this is one of the tests for the X. And then of course the last one is the arrival time. So when this AP send the signals to the stations, the response times back to the AP cannot more than 0.4 microsecond. Okay, so this is the time requirement. So we need to check with this one. Okay, this one we can check from using a spectrum analyzer. Okay, or with a spectrogram function. So from here you know the time response. Okay, we actually did some tests. The easier one, this is set up in our office. Okay, the easier one, of course, we can just use some phones. Okay, because the phone in the market now, they normally can support Wi-Fi 6. But 6 is not so popular in Malaysia, but Wi-Fi 6 is quite popular. Okay, so I think the latest phone, I think all the branded latest phone in the market can support Wi-Fi 6 now. Okay, so we put into our devices into the shoebox, okay, and then just connect to our tester. Okay, there's some LAN connections behind the control PC. Okay, and then first thing we are measuring the TB packets from the Wi-Fi 6 devices. Okay, from this measurement, you can see this is our measurement tools under our tester. Okay, so it's the AX standard. So the PPDU format is a TB trigger base, and then there's a RU allocations also. Okay, and then from here we get the 1024 QAM. Okay, this is the standard used by the Wi-Fi 6. Okay, so we can get this kind of measurement. Of course, we still a lot of measurement can be made. Okay, like power profile or power mass. Okay. Okay, then this is another measurement. So these measurements we measure like the CFO I mentioned just now, carrier frequency offset, or the unused tone error. Okay, unused tone error. So this is how it measures. Okay, this one cannot more than the limit line. Okay, yeah, this is some kind of measurements. And then we have the sensitivity test result. Okay, so sensitivity test we can also use a tester to check the sensitivity, because this is test the RS performance receiver part of your devices to check whether they can reach a certain sensitive level. So for example, if you start from very high power like negative 30 dBm, so you can set maybe 500 packets. So you set 500 packets. So see how many packets is lost. Okay, for example, in very high power like negative 31 dBm, you send 500 packet, so 500 packet received. So with this means a 0% packet loss. Okay, so when you keep lower your power until to the stage like negative 70, okay, they will see more and more packet losses. So somehow maybe you send 500 packet, maybe only 10 packet received. So at this kind of certain level, we know where is the sensitive level for your devices. So our tester can do this measurement also. Okay, sensitivity test. Okay, another new features about is the bandwidth allocation. Okay, if let's say today you're doing the DUT, so you want to check under which resource unit your your device using for the transmission, so you can actually set the allocation setting. Okay, so for example, this is the all the channels available. You want to transmit under certain resource unit, you can set it and then test it. Okay, for example, today this is one of allocation example setting. So if let's say I fully utilize all the spectrum here. Okay, when you see my spectrum emission mask, it will be like you fully under utilize 80 megas here. Okay, this is 80 megas. Okay, okay. If let's say I want to use this part only, okay, this part I can set here. So when you see the emission mask, you will see okay the performance for this resource unit only. Okay, so we can set and the resource unit specifically. Okay, we actually have a video, this online video. Maybe I can share to you later, and then you can watch the video. Okay, this is a video on how the test equipment works. But I think I will not share today. Okay, because I think we still have 20 minutes left. We still have some discussion later. Okay, but this is some videos you can get from later. I will share to you. Okay. Okay, all the testing here you actually can have automation. Can have automation. There's some automation tool. Whatever test you want to test, you just tick and run. Okay, this is everything check according to IEEE standard. Okay, so today I want to do AC, BGN. I can create my own test plan and then run, and then you can see some kind of test report. Okay, we make some test report. Maybe let me show you some kind of test report that I made. Okay, okay, for example, I have this kind of test report. So you have automations too. So once you run the test one time, you can get all the result here. Okay, this is like 6 gig. Okay, you can see the transmit power level. Okay, you will plot all the graph. Okay, under 60 meg, under the packet single user. Okay, so you're checking the emission power mass and then frequency tolerance. Okay, and then EVMs. This is the constellations, sensitivity. Okay, sensitivity. Yep. Yeah, you have sensitivity testing. Everything. You automations for you. I think it's a very useful features. So when you do the sensitivity search, okay, okay, this is automation part. Okay, I also want to introduce some kind of functional features, just in case that you may use it, you may need it. So some people may want to verify the IP version 6 or DHCP features of your devices. You can also use this tester because you have the setting to do it. You can also have the set the security. Then with this, the latest WPA3 PA3, so you can also verify it using the tester. And then if you want to do the live internet connection, so sometimes you are design your devices, Wi-Fi devices. So you want to check under whether you can go to live internet. So our tester is also allow the device to go through the internet, and then you can access internet services. For example, you can you can browse the YouTube. You can also browse other Google's website when you are using this tester. Okay. And then another one is check the protocol. Okay, this is mainly for troubleshooting because, for example, sometimes you want to check you can troubleshoot problem with the interaction between the AP and the stations. Okay, you can capture the protocol and then analyze it. We are using some kind of free open source software, Wireshark, to you can open it and analyze the message. Okay, to check what happens, any errors of the communication between your DUT and the tester. Okay, another famous thing to do is the speed testing. Okay, throughput testing. So this one it can be done also using, if let's say today you are DUT here, then you can doing some upload and download. So this site send data to the server side and the server send to the client. So you can check the upload speed and the download speed of Wi-Fi devices. We call this IP data transfer. So we are using some kind of open source tool also, the iPerf. Okay, with iPerf you can check your data speed. Okay, upload and download. Okay. Okay, yeah, that's all for the some kind of sharing of for Anritsu work on the Wi-Fi 6 study. Okay, so next I also want to share some kind of resources that are available from Anritsu. Okay, actually we have a very good website for WLAN resources. So you can, if you want to explore more, you can get some poster from here. Okay, you even can go some application note here. So we have a lot of application note for Wi-Fi related study. Okay, if you need the Wi-Fi poster, you can let us know also. After today, we can send you the link to download it. Okay, just let us know. Okay, so yeah, I also let you see how it looks like the Wi-Fi, our Anritsu website. So you have a lot of resources here. Okay, yeah, 6 gig. Okay, this everything can you can want to go for the application that I mentioned just now. You can just get it from here. Okay, yeah, yeah. Oh, okay. So if let's say feel free to browse our website. Okay. Okay. Yes, for review for today. So actually, I share about my company profile and my profile. So after that, I'm update the market situation, the Wi-Fi 6E situation to you. So basically, the 6 GHz frequency is something very new to the Wi-Fi standard. So yeah, and even the MCMC in Malaysia also start exploring it. Okay, then I'll give you some very technical or very theoretical knowledge about 11x standard. Okay, and then the key feature for 11x standard, there's about 8 key features, but the most important one is the QAM 1024 QAM, and then the OFDMA, okay, and the 160 megahertz bandwidth. Okay, this is I think the key features to increase the speed. Okay, and also to let multi users to use the resources. Okay, then next I also share some examples of how we help the industry players to do testing, like when they are doing the router design or doing the station design. Okay, then the next I share you some kind of resources available in Anritsu. So if let's say you are doing Wi-Fi related projects, you can go to a website and get more details also. Okay, I think this will be my sharing today. So I opens for any questions, Q&A sections. If let's say you have any questions, you can let us know. I will try our best to answer you. Yeah.
Okay, thank you,
Mm.
Mr. Lee.
Yeah. Yes.
Thank you for the very insightful knowledge on Wi-Fi 6 and Wi-Fi 6E,
Mm. Mm.
as well as the information on what Anritsu products can do, especially for testing
Mm.
purposes. So
Mm.
far, I don't see any questions in the
Mm.
chat box.
Mm.
If you do have any questions, perhaps you can post it in either in the YouTube chat box or the Facebook. We have two Facebooks live right now. One in
Mm.
the IEEE ComSoc Facebook and
Mm.
also the IEEE MMU Student Branch Facebook. Okay. So far there is no question. Maybe I can start the ball rolling with a few questions on this Wi-Fi 6.
Mm.
So you mentioned about the higher data rate. I think
Mm.
you can go if
Mm.
Wi-Fi AC can go about 9.6 gigabits per second.
Uh,
So now the Wi-Fi 6 should be able to go even higher. I think you mentioned about um,
yeah.
double or triple that of that
Yeah.
Wi-Fi
Yes.
AC, right?
Yes. Yeah.
Um, okay, so perhaps maybe people don't really realize how fast that can go. I mean,
Mm.
maybe
Mm.
you can sort of like share how fast it is to go with Wi-Fi 6, for
Okay.
example.
So okay. Just now, actually, you can see the this is a slide, or I'm actually sharing the slide. Maybe I
Okay,
can
I'll
talk
share
also.
the
Okay.
shares.
Yeah.
Okay, okay.
Okay. So you can see in the Wi-Fi 6 we can actually go up to 9.6 gig. Okay. Previously in AC is 6.9 gigs. Okay. And is a 500 meg. So so with the speed as enhancement actually can do a lot of things. Okay. If let's say observe the Wi-Fi actually even faster than 5G. Okay. 5G they aim for 10 gig, but they want is the plane, but in currently maybe they only can go up to 4 gig something only. Okay. But you can see Wi-Fi they are using in the indoor. Okay. They can go to 9.6. So with this you can realize a lot of the application that need a lot of data rates like the VR and AR. Okay, the virtual reality and augmented
Oh
reality.
my God.
Okay, yeah, yeah. So there a lot of application can be done. So the speed enhancement is of course first thing. The main thing is of course the modulation scheme. So from AC is on 256 QAM. So now you can go to 1024 QAM. Okay, means a 10 bit per symbol. This is only 8 bit per symbol. Okay, of course the bandwidth now is higher, and you are 160 meg. Okay, and then you also have the using the OFDMA scheme, so you can using the spectrums can save more efficiently. That's why you can increase the speed. So you want to now your speed is about 1 gig per second. So it's a very high speed. So normally this is a theoretically speed. Okay, it's RF throughput. So if let's say you want to count the IP throughput, maybe 75% of the RF throughput. So we can say it's about 7 gig per second for the
Mm-hmm.
data throughput. So with 7 gig per second throughput, you actually can do a lot of things. The download and upload should be very fast. Okay, a lot of application can be done. Okay. I think VR AR is the most most the application that need the highest bandwidth and speed now. Oh, there's of course the formula to count the 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 speed. Okay, so there are some kind of formulas, but to make it short, is related with the modulation scheme, the bandwidth used, and also the guard band used, which how many guard bands to be used, how many spectrum you use for data, and how it's used for the kind of guard bands application.
Okay, all right,
Mm, mm,
great. I think
mm,
I have another question since no
mm,
one
mm,
is actually asking
mm,
questions right
mm.
now.
Yeah, it's okay.
Um, it's with regards to that six
Mm,
gigahertz
mm,
frequency, the
mm,
Wi-Fi
mm,
6E
mm,
that we're
mm,
talking about.
mm,
And as you mentioned, only Malaysia so far
mm,
among the ASEAN countries that
mm,
have
mm,
actually
mm,
agreed
mm, mm,
towards this 6 gigahertz.
mm, mm,
Why is it taking a little bit slower compared to the other regions, for example? Or was there an issue in terms
mm,
of a conflict
mm,
of technology going, which is also using the 6 gigahertz band? Or is it
mm,
because of regulations and things like that?
mm. Okay. So for this, maybe I need to share some challenges when you deploy the Wi-Fi's six the 6 gigahertz frequency to be used for other users. Okay, I can see Malaysia. I think from what I heard, what I checked from the industry or the response from industry, so Malaysia should be the one that do a lot of study for Wi-Fi 6 gigahertz. Okay, uh, Malaysia should be the first one, but for 5G, not the first one. Okay, maybe Malaysia they are focused more on this 6 gigahertz first. Okay, and then first thing you need to make sure that when you want to implement the 6 gigahertz frequency, you must make sure that you will not interfere other uh, existing solutions. Okay, there are a lot of some existing solutions like the satellite services. Okay, and some broadcasting services are using the 6 gigahertz frequency. So I think maybe in Malaysia, maybe the Malaysia um, maybe have not much problem of this kind of a satellite service compared to other regions. Okay, maybe I think other region maybe like Indonesia, they have a lot of satellite services because they have a lot of their land maybe are too they need a lot of these kind of satellite services
Yeah.
for their area. But I think maybe Malaysia's they after survey they may be fine. They have more chances to use this 6 gigahertz frequency. So I think Singapore wise, maybe they are still considering whether to implement. Sometimes they are also want to check the market demands. So whether there's a real need for the market demand. So some may say that the Wi-Fi 6 is enough, 2.4 gig or 5 gig is enough for the market. Okay, some may say not enough. So it depends on the market demands also. Okay,
Mm.
so yeah, I think this is some kind of factors that affect the deployments of Wi-Fi 6 gigahertz in our regions. Okay.
Yeah. Okay.
Mm,
Thank you.
mm,
I think
mm,
that we had some discussions on
mm,
the 6 gigahertz as well. There was a
mm,
debate, and there
mm,
was a public
mm,
inquiry given by
mm, mm,
MCMC to get
yeah.
the feedback from
Mm,
all
mm,
the
mm,
stakeholders,
mm,
and all the stakeholders
mm,
have already given their feedback.
mm,
So
mm,
MCMC has announced that we're going to have certain frequency band for indoor and certain
mm,
frequency band for outdoor, which I
mm,
believe is quite similar to what
mm.
has been implemented in South Korea.
Yeah, I think
Mm,
South Korea or US or a lot
mm,
of other
mm,
country. Yeah. Mm.
mm.
I think it's a good
Okay.
initiative. Yeah, from MCMC. Yeah. Mm,
Yes.
yeah.
Okay. All right. I think there seems to be no questions from the
Mm,
audience.
mm,
Hopefully, everybody has obtained
mm,
the necessary information on Wi-Fi 6 and Wi-Fi
mm,
6E.
mm,
So soon we'll be actually, as mentioned by the Mr. Lee just now,
mm,
most of the newer phones actually already
mm,
have Wi-Fi
mm,
6. It's just that the access point is not
mm,
equipped with
mm,
Wi-Fi 6. So
mm, mm,
even if
mm,
your phones already have Wi-Fi 6, you may not
mm,
be able to
mm,
use it yet. So it
mm.
will be
Yeah,
coming soon
yeah,
to your homes
yeah,
later, I guess.
yeah, yeah. Wi-Fi 6 IP is available, but normally it's very expensive. So I think
Mm,
for normal user, you just buy a maybe under $100 AP to use
mm,
in the home. I think if let's
yeah.
say Wi-Fi 6 router can be up to 1,000 maybe in the market. Mm.
Mm. And most of the time, we actually got it together with the subscription. So we got
Yes,
the
yes, yes,
free
yeah,
access points
yes,
with the
yes.
mesh
Mm,
routers and so on. So
mm,
we don't
mm,
really go and buy our
mm,
own routers
yeah,
and so on.
yes,
Mm.
yes,
Uh,
correct. Yeah. Mm,
yeah. Okay,
mm,
I guess since there is no basically there's no questions.
mm,
Thank you very much,
mm,
Mr. Lee. Do you want
yeah.
to share the website or that they can actually download the materials if they wish
Yes,
to
yes, yeah.
have a
I
look
will.
at
How
it?
how can I will type
You can
here?
type it in the comment and then I can share it in the
Yeah,
banner.
yeah. I type in the comment or comments. Okay,
You
then
can paste it in the comments side.
comments. I do in the private chat, but comments side I cannot type.
Oh, okay, you did it in private chat. Eh? Okay, let
Yes, yes.
me share this to
Mm,
everyone in the I can share in the banner.
mm,
So this will be the
mm,
website that for anritsu.com,
mm,
which is the website for the testing.
mm,
Um, I think that's the only one that I managed to get.
mm,
Let me try this again.
mm,
So that's the
mm,
one, anritsu.com, and you
mm,
test measurement
mm,
technologies w9
mm.
c
Yes,
60
yes,
feature.
yeah. Mm,
Okay. All right.
mm,
So
mm,
once again, thank you very much, Mr. Lee, for your
yeah,
time,
yeah.
and hopefully
Mm,
the audience have obtained the necessary information from the talk that we have prepared for them. Right.
mm,
So
yeah,
perhaps maybe we'll see each other again in the future for future
yeah,
events.
sure,
Mr.
sure,
Lee,
yeah.
yeah.
Thanks, yeah.
All
Thanks.
right.
Love
Thank you.
yourself.
Take care. Take
Take
care.
care. Yeah.
Okay.
Okay. See you.